Hi guys, so we're into, can you believe it, week number 7, which makes 9 weeks or 8 weeks or 9 weeks since we've actually been together in a classroom. I suppose we've no choice, but we'll keep going and keep motoring through these topics, so we're staying where we need to be by the end of the second year course, which is exactly where we are at the moment. So you're all doing absolutely deadly. We're flying through this. What I asked you to do on Friday was this here, so the revision exercise, 2, 4, 5, 7, 10, 13 and 15, but there's loads of questions there. Looking at your homework, I don't think anyone had any bother with anything we did last week, so there's lots of questions there, ones that I ticked for you to do on Friday as part of the class, but there's loads of other ones there, and what I've done is I've put the solutions over here to all of those on the right hand side, so you can check your answers against them and go back and try them again. Any other ones that you haven't done, if you want to revise what we did last week. Okay, or any questions around that exercise and you couldn't do it, and send me an email and I'll stick in a solution in the middle between the questions and the solutions there for you. And I'll send you an email to let you know I've done that. Okay, so any problems, just let me know. Okay, right, we're going to mosey on, so we're going to keep going on. I said we're not doing CBA until we get back. I spoke to Miss Connolly, Mr. Pryor last week, and we decided to leave it because the science CBA is starting up and there's other CBAs running, so we leave maths. It'll only take us 2 weeks max to get the maths CBA done, so I'm not worried about getting that completed in time, but we'll get it done when we come back to school after Easter. So we're going to mosey on, right, and look, we're sticking with this kind of area, volume, perimeter type thing. We're just going into slightly more detail. Still in book 1, but it's book 1, chapter 27. So it's a different chapter, but it's the same topic, but it's looking at, as opposed to nice things like length by width and length by width by height, this goes into looking at area of things like triangles and circles and things like that, which you don't have length, widths and heights in some of these shapes. Okay, so again, just a couple of reminders. If you want the area, is the amount of flat space that a shape occupies. So we've worked out area before, and we've also worked out surface area. You were doing that last Wednesday. Perimeter is all the way around the outside. So all the way around the outside is the perimeter of a shape, and that doesn't change. Area and perimeter are the same, no matter what you're looking at. So just go up. If we go up a level, if I have this shape here, on the left, and I want to find its area, so this is what I would imagine is a rectangle. So I have the length by the width, so 6 by 4, which gives me 24 centimeters squared. But if you have a look down, there's a line drawn down the center of this one, which separates it into 2 triangles, triangle A and triangle B. So if we're saying if the area of the rectangle is 24, and those triangles are the same because the line is drawn directly from corner to corner, then if you half that, the area of each triangle is 12 centimeters squared. Same over here, 8 by 8 gives you 64 centimeters squared, length by width. C and D are the same. So if you half 64, you get 32. So you can find the area of the triangles by halving the area of the rectangle or the square. Okay, our first formula. If you want to find the area of a rectangle, you multiply length by width. Same as a square. If you want to find the area of a triangle, you need a formula. And the formula to find the area of a triangle is half the base multiplied by the perpendicular height. So half the base multiplied by the perpendicular height. The perpendicular height is the height from the surface all the way up to the top. Okay, so this line here, is not perpendicular height. The perpendicular height is this one here. So that's perpendicular height. So straight up at a 90-degree angle. Okay, so that's the way you find it. You're thinking, I'm going to remember all these now because I'm going to throw a load of formulas at you. But the good thing about these is all of these are in the log tables, which you can take into your exams in the summer, which you can take into your exams in the junior cert, which you can take into your exams in the leaving cert. So half the base by the perpendicular height. You just need to know when to use the formula. That's the trick. Okay, so if half the base by the perpendicular height, here's 2 examples here. So if I have this triangle here, so and I'm thinking, right, my formula to find the area of triangle A is half the base by the perpendicular height. So our base is 10 centimeters and our height going straight up is 7 centimetres. So the way we work that out, we have half of 10 multiplied by 7, which is going to be 5 by 7, which is 35 centimetres squared. Over here, it's the same thing. Here's our base here. Our base is 8, and our perpendicular height is 5.6. So you're going to have half of 8 multiplied by 5.6. So it's going to be half the base by the perpendicular height. Half the base by the perpendicular height. Another example here, and these are all out of the book. You can go into the book and have a look at these. A regular hexagon. Okay, so hexagon has 6 sides. It's made up of 6 congruent triangles. So you've 6, remember we did a whole chapter on congruent triangles. Triangles that are all the same. Each triangle has a base of 5, so a base of 5, and a height of 4.3. Find the area of the hexagon. So if we find the area of, say, this triangle here, we can multiply that by 1, 2, 3, 4, 5, 6, and we could find the area of the whole hexagon. Okay, so here's our numbers, here's our base, and here's our height. So we get, again, same formula, half the base by the perpendicular height. So half of 5 multiplied by 4.3, which gives you 10.75. And because you have 6, multiply that by 6, which gives you the total area of the full shape. Another one. And you can pause this and go back and listen to it twice, 3 times, or go into the book and try them yourself. You know, it's up to yourself. Depends on how quickly you kind of catch on to it. The area, this time they've given us an area. 42 centimetres squared is the area. And the height is 8 centimetres. Okay, so they've given us the height, but they're not giving us the base. So remember, we stick with the same formula. Half of the base multiplied by the height. So we know that the height is 8. So we know, so we have H, but we don't have B. So the way they work that out is they half the base by the height is 42. So they sub in for what they do know. So half, they don't know what B is. Half of B by the height, which is 8, is 42. So if you work that out, half of 8 is going to be 4b is 42. So 4b is 42, b is 42 over 4, or b is 10.5. So using this formula here, they can give us anything. They can give us the base and the height, ask us to calculate the area. They could give us the area and ask us and the height and ask us to calculate the base, or they give us the area and the base and ask us to calculate the height. Once we have 2, we can work out 3, very like Pythagoras when you did it before Christmas. Okay, and here's these are just exercises working out. So it's separate. This chapter separates it all into different exercises. So as normal, we'll do a few of those as we go along. So I'm going to tick question 2, question 4, and question 8 for you to try a couple working out the area of a triangle. Okay, and we can do them when we get to the end of the video. We do one more formula today. All right, so half the base by the perpendicular height, remember that. The second one is this one here, looking at discs, so circles. So having a look at circles. So first one was triangles, second one was circles. And do you remember this diagram? You remember this, and you drew it out, and you came across different kind of terms. Circumference all the way around the outside. Radius from the center to the outside. Diameter all the way across the middle. So you have a look there, you have a diameter, a radius, and a circumference is all the way around the outside. So we need 2 formulas there to be able to work them out. And we have both of them here. If you want to find the area of a circle, it is pi r squared. Pi multiplied by r squared. Okay, and we get to how to work that in a minute. The other one, all the way around the outside, circumference, is 2 pi r. Okay? So people ask you, well, what's pi? You might have come across pi. If we get the circumference of a circle So we get the level all the way around the outside. What's the measure all the way around the outside of a circle? And then we get the diameter of any circle. Any circle, doesn't matter what size. Could be a circle the size of Leinster. It could be a circle the size of a 2-cent coin. Doesn't matter. When you divide the diameter into the circumference, you always get pi. And pi is 3.14, sometimes written as 22/7. They're the same thing. If you divide 22 into 7, you get 3.14. Okay? So, and again, do I have to remember half the base by the perpendicular height? Do I have to remember pi r squared? Do I have to remember 2 pi r? No, you don't. In the tables booklet, you have those there for you. Formula and tables booklet has half the base by the perpendicular height, has pi r squared for the area, and has 2 pi r for the circumference. Again, the trick is just knowing when you need to use those formulas. And we'll get used to that as we go through the questions. So here's one full question done out for us. It's done out in the book, so you can check these out. So if we want to find the area and the circumference, so two things. We want to find the area, so they're going to get us using both of these formulas, and the circumference of a circle. The radius, so r, is 8 centimeters. Now, and this is why I put this in here. In terms of pi, when they write in terms of pi, that means pi is in the answer. Right. That means pi is in the answer. So pi is in the answer. If they want you to, if they say using pi is 22/7 or using pi is 3.14, that means that they want you to sub in for pi. So put in something for pi. And they can also, there's a pi button on your calculator. Check that out in your calculator. So you can put the pi straight into the calculator. But if they say in terms of pi, it means you do not sub in for pi, and pi is in your answer. I'll just show you what that means now. So if we want to find the area and circumference of a circle in terms of pi. So let's start with part A. So, well, first off, the formula to find the area of a circle, here it is. Area of a circle is pi r squared. Don't have to remember it, it's in the log tables. So we sub in what we know. We know that the radius, or, is 8. So if you have a look at what we're doing, pi r squared. Pi by 8 squared. And because it's in terms of pi, that means pi is in the answer. We just, 8 by 8 gives you 64, and pi is there in the answer. So if it says in terms of pi, pi is in the answer. The second part, part B, same sum, except this time they want us to put 22/7 in instead of pi. So exactly the same formula. Oh, sorry, part B, 3.14. So we're going to end up with pi r squared, same formula, but this time, instead of pi, we put in 3.14. The radius is the same, 8 squared. And when you put that into your calculator, you get 200.96. The next one is using 22/7. So, area of a circle, same formula, pi r squared. This time, instead of using 3.14, use 22/7. It's a decimal place kind of thing. So pi r squared again, and you get 201.17. So you see there between these two answers here, there's a very slight difference. So that's why they have to tell you whether you're taking pi as 3.14 or whether you're taking pi as 22/7. But the pi is pi. It's the same thing. It's just one's using a fractional, one's using a decimal. And the last one, using it on the calculator. So you have pi r squared, same thing, which works out as 64 pi, which works out at 201.0619298. So it gives you a load of decimal places after that. But that answer and that answer, so this one, and this one, if you have a look at them, they're all roughly the same. There's very, 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 very little between them. Okay, and you won't be done unless they tell you in particular that you're to use 3.14 or 22/7 or the calculator. All of those would be correct. Okay, so pi r squared, our first one. The second formula, they asked us to do the second part of the question was to find the circumference. So our different formula here is 2 pi r, again given in the log tables. So we just sub in straight away, but remember in terms of pi is 3.14 and pi is 22/7. So we sub straight into the formula. 2 pi and r is 8, and that works out as 16 pi centimeters squared. Using 3.14, we end up with 2 pi r, and that gives you 50.27. So when you sub that into a calculator, it gives you 50.27. Same again, 2 pi r, which gives you 50.2. Okay, so you see there 50.24 and 50.27 are ever so slightly different because in this case you've used 3.14 and this case you've put in 22/7, but they're both pi. Finish it off then, put it straight into a calculator, and as it looks like on your screen, hit 2, hit pi, hit r, so 2 multiplied by pi multiplied by 8, 2 pi r is 16 pi, and that'll give you a big long decimal place, so 50.2654, which again, these answer and this answer and this answer are very, very similar. So, but they're all correct. So just be careful of the way they ask the question. Do they want you to leave it in terms of pi? Is this going to be pi, or is it going to be 3.14? So just be careful with the way they ask you to, how are you doing? Are you leaving pi in the answer or are you not? Oftentimes they won't. They'll give it to you either way. But just in case, be careful the way you read the question. Circumference of a circle is 44 pi millimeters. So 44 pi millimeters, that's the circumference all the way around the outside of a circle. Find the length of the radius. Okay, right, so, well, they're giving us the circumference. So what's the formula for circumference again? Here it is here, 2 pi r. Okay, so here's the circumference of it. There's the formula there. So they're telling us now that the circumference, 2 pi r, is 44 pi. Right, so what they want us to find, they want us to find the radius. So we want r by itself. Well, if 2 pi r is equal to 44 pi, what we can do is we can cross out pi on both sides. So there's pi over there, and what that leaves us with is 2r is equal to 44, or r is equal to 22. So if you have pi on both sides, you can divide both sides by pi, and what that does essentially is gets rid of the pi, and you're just left with r is equal to 22 millimeters. Okay, so it's a couple of examples here because they're all kind of different, but the same as well. So, other one, the area of a circle. You see, they're going to tell us what pi is here. The area of a circle is 98.56. They're giving us the area. What's the radius? We're looking for the radius. So write down what you're given. Okay, right, they're telling us that the area is 95.56. So that means, here's the formula, pi r squared is 98.56. They told us what pi is, 22/7, so they write it again. Pi r squared equals 98.56. Okay, so what we're going to do is, we're going to, say the 22/7 wasn't 22/7, say it was 2r squared is equal to 98.56. What that would mean is you divide the 2 into the 98.56. We're going to do exactly the same. We're going to divide 22/7 into 98.56, and that will give us r squared. That works out as 31.36. To go from an r squared to an r, you get the square root, and that gives you an answer of 5.6 in the end. If anyone's confused on that now, ask me in the live class on Wednesday, and I can do another one of those. Or you might find a question similar in the homework that caused you a bother, and we can do it out on Wednesday. Okay, our last example is diameter of a 20-cent coin is 22.5 millimeters. Now be careful, diameter is of a 20-cent coin. They're telling us pi now is 3.14. Calculate the circumference of the coin. Okay, right. So the way you calculate, let's go have a look at part A first. So if they're saying, well, right, first off, they've given us the diameter. So we know that all these formulas, pi r squared and 2 pi r, the area and the circumference, always looks for the radius. So if the diameter is 22.25, we divide that by 2 to get the radius. And that's 11.125. Now we can use the formula. And the formula to use circumference is, as it always has been, 2 pi r. They tell us pi is 3.14, so here it is, 2 pi r. And that works out as 69.865 millimeters. That's how you work out the circumference of a circle. Part B, the distance travelled if the coin makes 10 complete revolutions. So if you basically turn the coin aside and roll it, how far would it go if it went around 10 times along the ground? Okay, so the distance travelled. So we've worked out that it's 69.865 millimeters. So if you move the decimal place, that works out as 6.9865 centimeters. Okay. So multiply that by 10, and that's going to be 69.865 centimeters, like that. Okay, well, so we worked out the circumference. So the circumference is 69.865 millimeters, which is 6.9865 centimeters. But if that was to do the circumference 10 times, it would bring us 69.865 centimeters in total. Okay, and the last part then, the number of complete revolutions the coin makes if it rolls a meter. Okay, well, if 1 centimeter or 1 meter is 100 centimeters, as you know, as we started off this chapter, one meter is 100 centimeters. The number of revolutions, so the distance it travels, is the total distance it travels over the distance travelled in 1 revolution. So how far would it go if it spun once over the total distance travelled? So it travels 100 meters over 6.965, which we worked out, change colour, there, which we worked out there. And that gives us, you round it down, 14 revolutions. Okay. So, and what I want you guys to do for homework, I'm going to give you a couple of these to tap away at as well. And if there's any issues, you can give me a shout, and we will be correcting these the next day as well. Okay. So what I want you to do, I want you to try question number 4, question number 7, and then some of these technical ones here, question number 14, question number 11, and question number 16. So I'll write these out at the side for you now in a second, the 2 exercises for Monday, so, or for Wednesday. We call it Monday's class and homework because you'll have more time in the hour this morning to go through some of these. So it's going to be exercise 27.1 and exercise 27.2. So in 27.2, it was question 4, 7, 11, 14, and 16. 4, 7, 11, 14, and 16. So that'll bring you through just using pi r squared and 2 pi r, and then into some more of those technical ones like we saw with the coin. And if you remember back here, in exercise 27.1, this is the other thing I want you to remember. So there's 3 formulas today. Half the base by the perpendicular height to find the area of a triangle. And the area of a circle and the circumference of a circle, pi r squared and 2 pi r. So 3 formulas. And I'm not even asking you to remember them. I'm just asking you to be able to use them because they're in the log tables. So question 2, 4, and 8 in exercise 27.1. 2, 4, and 8. And again, we'll correct those the next day, and we'll move on to a few more questions and a few more different shapes on Wednesday and on Friday. But we're motoring through. We're doing really well. You're all keeping up. All the homework's done, which is fantastic. And anyway, mind yourselves. And any questions, you can send me an email, or if not, I will go through all these solutions on Wednesday. So take care, mind yourself, and I'll talk to you on Wednesday.